Welcome to WXTV, your online source for weatherization training. Today's episode focuses on the safety and efficiency of gas forced air heating. Our master plumber Mike will take us through the steps that a weatherization professional would use to test, clean, and tune one of these popular systems.
Well, hey Mike.
Hey Ben, nice to see you.
Good to see you. What are we going to be doing on this furnace today?
We're going to do some diagnostics on all the combustion appliances, make sure they're running correctly. Want to make sure that everything after the weatherization work's done, that it's still going to work right, and fix anything that needs to be fixed for safety reasons and so forth.
Going to do a clean and tune also?
Yep, we'll pull the blower motor, clean it, make sure the filters are replaced, and anything that needs to be cleaned up to make the furnace run efficiently, we will take care of that as well.
Good. Well, lead the way. Let's hop in and check it out. Hey, Mike.
Oh, hey, man, just in time.
Let me give you a hand with that.
Thanks. Okay.
You got it?
Yep. Yeah, and I gotta get this measurement over here.
Okay.
Grab that one there. Okay.
Deal. So what are we measuring?
Well, I'm trying to figure out how much volume we have in this room so that I can determine if there's enough combustion air supplied to these two appliances, this water heater and this furnace here. So,
How do we know how much these two appliances need?
well, what I did is I looked at, this is a 138,000 BTU furnace, and this is a 34,000 BTU water heater. So total I need 172,000 BTUs of fuel input. And when I use the codes, it tells me that I need 50 cubic feet for every 1,000 BTUs. So I do the math, and it looks like
Is this going to make it?
no, this is only good for 66,000 BTUs. So we're going to have to prescribe direct combustion air from outside into this room,
Gotcha.
and that'll make these burn better.
All right.
So,
Well, what's our first step then, besides determining if it has enough combustion air?
well, when I come into one of these rooms, that's usually what I do. Is I just take a look at the appliances, look for problems like, for example, this is duct tape here.
Not good for ductwork, despite the
No.
name.
No, for one, it's a combustible, and this is the flue pipe, and this has to be 6 inches from any combustible. So this actually could start a fire. So this is not appropriate
So we'll
here.
get that fixed.
Yeah.
All right.
And at first I just generally look around, look for obvious problems before I start all my diagnostics work. But
Okay.
I always look at combustion air. That's the first thing I look for.
All right. You ever just start it up then?
Yeah, I do.
Yeah?
Yeah.
Can we start it?
Yeah. We power's on. We have to go upstairs and turn the thermostat on, and we'll get this thing running. You want to hear it run?
Yeah, let's
All
hear
right.
it. You
Let
gonna
me go
head
get-
up and start it?
Yep, I'll go do that.
All right, good deal. Yeah, I think it's running, Mike.
Yeah, I can hear it from here.
Yeah,
That's a loud one.
yeah, she purrs.
Yeah.
All right. So we got it running. You probably need to check how much gas it's using, huh?
Yep, this is a natural gas system, so right now would be a really good time to go out to the gas meter, and we'll clock the gas meter and confirm the right amount of fuel is being supplied to this furnace.
All right, let's go check it
Wanna
out.
go check it?
Yeah. So is the gas meter in India somewhere, or?
Yeah, it might be. The meter reader might not like this place. Look at how easy it is to read this meter. The meter reader has a trail to the place. Holy cow. There's got to be a better
Hmm. You find a way in, Mike?
Yeah, this is not an easy meter to get to read. Okay, this is like the hardest meter I've ever had to read. Okay, so we're clocking this meter. The furnace is on, and we're going to time how many cubic feet go through this thing in a certain amount of time. And boom, here we go. Okay, so we have 1 cubic feet in 10, 20, 25 seconds, and I'll use that. 1 cubic foot in 25 seconds. Oh. Welcome to the jungle. Oh, hey, look at this. Look at this dryer vent here. It's, most of it's covered up.
Notice that.
Looks like mice can get in there pretty easy too.
Sure does. Yeah, no anti-critter
Yeah.
mechanism.
Yeah, that probably needs a little work.
Well, Mike, what'd you find out?
Well, Ben, after doing the math, it looks like that furnace is burning 124,500 BTUs per hour. Now, that's 138,000 BTU furnace, so
Sure.
that looks a little low. However, we're at an elevation of 5,000 feet here.
Right.
So for every 1,000 feet above sea level, we have to derate 4%. So really, we need to derate this by 20% here. So that comes out to 110,400 BTUs per hour. So it looks to me like we're about 12% over firing. And what we need to do is we'll put the combustion analyzer on there and see how well our burn really is. That'll tell us a whole lot. But we may need to put smaller orifices in
Okay.
because this is over firing.
Overfiring, we could get some sooting and some carbon monoxide
Yeah,
problems.
exactly.
Okay.
Exactly.
Good deal.
So,
Well,
yep.
it looks like you've got a lot of work to do, and I've got a few other houses to check on. So I'll let
All
you
right.
get to it. Thanks
see you
much.
later.
Yeah.
Thanks.
Take care.
Okay, so a couple more things we'll take a look at on this unit are these two units. Looks to me like this is the relief valve for the water heater. I know we're talking about furnaces here, but this is supposed to be within around 6 inches off the floor. And so we would actually prescribe a addition of some pipe to this to get it to the floor. That's a code requirement. Another thing I noticed is the draft hood on this is part of it's out of its place. It's kind of at an angle. We'll probably try to fix that as well. And then real quick, usually what I do is I'll measure the ductwork, the return. This is 10 by 23 inches. So I have 230 square inches of return air. I need 2 square inches for every 1,000 BTUs of output. And when you do the math on 138,000 BTU furnace, 70% efficient, that becomes 96,000 BTUs of output. So I need 96 square inches, and I have 230 square inches. So I have plenty of return air. That's a pretty good sign that my ductwork is sized big enough. The next step is I usually just open these up and take a look at what's inside. Okay, so we'll take a look at what's inside this unit. This is a standing pilot furnace. Here's the thermocouple. Inside here I can see that the pilot's lit. Here's our gas valve. Looks like this is a 24 volt gas valve, natural gas. We do have the ability to shut the gas off to the pilot with this manual valve right here. There I just shut the gas off to the pilot. Once the pilot's out, if the thermocouple cools down, then this valve shuts off and will not let gas go to the manifold here. This has 4 burners. These are actually monoport burners. They're some of the first monoport style burners that I've seen. They actually shoot a flame into the heat exchanger. That click that was the thermocouple. It had cooled down enough to where this electromagnet let go and shut the gas off for the whole gas valve. So now there's no way for gas to get through the gas valve. Up here is we have our fan control and our high limit. This has a probe that goes into the heat exchanger. If this gets hot enough, too hot, it will actually break the power to the gas valve so that the gas shuts off and cannot continue to burn. So it has a safety built into it. It also has the ability, when the temperature gets to a certain amount, it turns the fan onto this furnace. And also after there's been a call for heat, it turns the fan off when the temperature of the air gets down to a certain temperature, and that's adjustable in here, and that's set at 95 degrees right now. So that's actually a good setting. We recommend 85 to 95. Take a look at the fan on this. This is a upflow furnace. Our fan sitting down on the bottom here. Let me grab my flashlight here. Looks like we have a little bit of an issue here. The filter has been sucked into the pulley of the motor. It's actually riding up against both pulleys. This is somewhat common when there's no supports to hold the filter in place. And you can see all the fiberglass shavings that have collected into the motor from rubbing up against the filter here. So we'll go ahead and pull that filter out. And you can actually see the imprint where the belt has been riding on that, and all this fiberglass is gone. And then you can see how dirty this filter is. This is pretty dirty. That's probably one of the reasons why it got sucked into the fan, is from all the dirt that collected and plugged up the filter, so it created more of a suction to the fan. Okay, I reinstalled the bracket that holds the filter in, and I did reinstall the dirty filter. And the reason I want to show what the heat rise is one of the diagnostic things that we measure to see how efficient and how much air we're moving through the furnace. The key is to move as much air as possible, and a high heat rise is usually
caused by a dirty filter or too small of a ductwork. Anything that restricts airflow gives us a high heat rise. So a dirty filter, this should show us a high heat rise. I reattached the bracket and I screwed it on so that that shouldn't happen again, where the filter gets sucked into the blower. So anyhow, we'll go ahead and put the covers on. We're going to measure a few temperatures here. One is we want to get the temperature of the air when the fan comes on. After about 5 minutes of runtime, we want to get the temperature of the heat rise. That's the difference between the return air and the supply air. And then after we turn the furnace off, we're going to get the temperature of the air at the fan off temperature, which should be about 95 degrees because we get to adjust that from this control here. I'm going to put the covers back on and then we'll do that. Okay, a bit more about this furnace. This furnace, one of the things we look for is how old is the furnace. I look for any clue that tells me how old the furnace is. I know for, based on this house, this is the original furnace installed in the house. I can tell it just from experience. So it's at least 20 years old. But one thing I did find in here is this is the City of Bozeman gas inspection tag from 1976, which this is authorizing the gas line work. So this house was built in 1976. That's when this furnace was installed. So I have a pretty good idea based on that tag. And sometimes you can find stuff like that laying around. This is a natural draft furnace, so the draft hood's right here. It drafts naturally up through the chimney, which is B-vent, and it's probably somewhere between 60 and 70% efficient. We'll get an idea when we take the combustion analysis on it.